Coach Jay, what is up? This is Cyber Day, January 17th, 2018. We're getting rolling today, and hope you're getting rolling too. I know probably some of you are just rolling out of bed and getting it going. We'll give it a little shot here. A little short. Hey, again, hope you're having a good time there. I hope the Cyber Day work wasn't too much. There is, I know Cyber Day, the expectation is still there. Hey, turn in that assignment by midnight tonight. But if there's too much going on with y'all being seniors, just own it a little bit and let me know. And I think the big thing is you let me know. We can adjust and go from there. For my Precal12, I know it was a 23-minute podcast with finishing that homework of 2.1a. And then for my AP Stats, I know it was a little bit longer with the 40-minute podcast. A lot of that was just review over stuff we've already talked about, and then kind of transitioning to the new material. And with AP Stats, again, that new material is what the test will be over. I wanted to not only have podcasts for y'all, stayed up late trying to get those podcasts in, but I wanted to provide just an hour of time for y'all to ask questions, show up, and leave when you need to. This is not a requirement, but it's just simply, if you have any questions, we can go through those together and go from there. Right now, I know that I've got one viewer here, so feel free, text me, email me if you're struggling with something, if you have a homework question, if you have a concept question, if you're saying, hey, coach, could you just do the FRQ with me? Or maybe you have another FRQ you would like for me to do, or a homework question, or really this is literally your time. So I wanted to give about an hour to just kind of answer any questions you have. So again, chat, email, or my phone. I'll keep all of those devices at hand to where we can access those accordingly. I'll probably not post this, so if people want to go back and look at it, they can use the link, but probably not going to post it because this is kind of a mixture of, if you could think of it as like a morning health session. This is Precal12 as well as AP Stats. If it's well attended, maybe I might do one later this afternoon if it was something that people needed. So continue to communicate with me, and we'll go through those accordingly. Other than that, if you have got questions, I'm going to be around my email after 12. So feel free to answer those or ask questions, and I'll answer those as best as I know how, even if I've got to FaceTime you and talk through that together. So with that being said, I'm going to get started. I know, again, I see a couple viewers here. So if you are accessing this at this time, this is for you and you alone. This is not, I have no set agenda here, but feel free if you have a question on a homework or any problems whatsoever, let me know. Or even you maybe have some confusion on the expectation for today in your other podcast. But again, I just wanted to help however I can. So feel free. Post, and in fact, I'll post right now. Post here on the live chat, or if you would like to, feel free to text me, email me, whatever that may look like there, okay? So with that being said, come on with some questions. If you've got some questions, I've got everything set up. We're ready to go. And again, feel free to post those questions there. So I'll hold off for a second as y'all get squared away and get those questions to me. And also, if it's AP Stats that y'all are in, I don't think it allows me to see who is on here. So if you could just tell me if you're in Precal12 or if you're in AP Stats, that will also help me, because if we're in AP Stats, we could also do that FRQ if you've already attacked that, or if you have a different FRQ, we could do that as well. Whatever you're thinking there. Again, this is for you. Let me know if I can help in any way. Hope Cyber Day's going well. Hopefully it's not been too crazy with all the teachers giving work here. I know with AP Stats, as I know some of you are getting some of your questions in. I know with AP Stats it took a little bit longer. To do there, so I completely understand. If for some reason you have some issues with that, just let me know. The FRQs are to be done. Those 2 FRQs were supposed to be done anyway by this coming Monday. And so I just was trying to do some just keep doing things, try not to add to it, but just trying to get you to do a couple of those so we can have less homework due on Monday. All right, let's go over number 7. This is a Precal12 question, but I'm going to bounce back and forth. So if you're in AP Stats or Precal12, again, this is a help session. I'm just going to go back and forth between it. So feel free to do what you need to do to get that done. All right, Dalton, I'm going to switch screens here. I appreciate you for showing up. I really do. I'm going to go through. I'm going to go to this here. 2.1a, number 7. Let me get this homework pulled up so I can see it. All right, number 7 says use a graphing utility to graph the quadratic function. Find the x-intercepts of the graph and compare them with the solutions of the corresponding quadratic equation when f of x equals 0. Now, we haven't really talked through the quadratic equation, so I know that might be a little weird. One of the things, though, that we do know is in plugging this in, I'm going to get this set up here. Number 7. Let's do it here. Okay. So once I have y equals negative 2x squared plus 10x, I want to make sure that that was correct. Yes, it was. They're asking for a couple things. First off, it said use your graphing calculator, which you don't have to use, but you can. And it said find the x, the y-intercept, and so on and so forth, okay? And probably find the vertex and rock and roll. The one thing that they did say, and what I'll kind of show you is kind of both parts. First thing they want you to do is kind of use your graphing calculator to find the y and the vertex. Since this is not in vertex form, this is in standard form. Remember, the vertex form is as follows. This is what we did in class a little bit. And then on the podcast, when we did ax squared plus bx plus c, that would be in standard form here, okay? Right there. So to help us out a little bit with this, since it is in standard form, you could do your negative b over 2a as I showed in the podcast and then plug it in to get my y, right? Plug this in for x to get what the y is. But I can also use my calculator, which I'll show you here in a second. It did say to either check or to use the algebraic method to be able to find my x-intercept. So really on a test, I'll either have you have a calculator or not. So it's kind of a little strange here because I kind of want you to do both. But we'll just follow it just so you can kind of see the different ways of doing this. And oh, by the way, you could do this by a graphing calculator as well, okay? And actually the y-intercepts, let's do this. Let's hold off on that. Let's do this algebraically and this one algebraically, and then do this one, the vertex, by graphing calculator, okay? So for the x-intercepts, we plug 0 in for y, and it says 0 is equal to negative 2x squared plus 10x. Now, there's a bunch of different ways we can approach this in terms of solving for the values of x. One of the ways is if it's just 1x, we can just solve for x like we would do on a basic level. But with 2 x's here, we can either go 2 ways. We can go factoring, or you can do the quadratic formula. Both would be sufficient. I think it said to use the quadratic equation or quadratic formula. Either way is fine. If it's factorable, I always like to do that method. So I'm going to do actually that method here, although you could do the quadratic formula, which is negative b plus or minus the square root of a squared. This plus or minus the square root of b squared minus 4ac all over 2a, right? So just be sure of that. So negative b and then all of that. But the factoring, if I factored, I could say what value could I take out of both of these terms? Well, if I took out, let's say, a negative 2, because I like to make this x squared positive, and really a negative 2x because both have x here, I could say what's left over. Well, if I took an x and a -2, I have an x left over. And if I divide -2 into 10, I get -5. And since I took an x out, I just keep it as is. So once I factored this, we could just set simply both equal to 0. So x minus 5 equals 0 and -2x equals 0. And then I simply solve for x. So I solve for x here by adding 5 to get x equals 5 and x equals 0. So my x-intercepts would be 0, 0, and 5, 0. Okay? All right, so we've got that there. We got the x-intercepts. Let's do the y-intercept. The y-intercept's a lot easier because I can plug, remember the y-intercept, I plugged 0 in for x. So I plug it here and here. So 0 squared is 0 times -2 is 0 plus 10 times 0, so 0 plus 0 is 0. So my y-intercept would actually be 0, 0 when I plug 0 in for x. Okay, so I've got my x-intercept, my y-intercept. We've got most of that there. Now, here's what I'd like to do now. I'm going to take out my calculator here. I'm going to wait on that. I'm just going to show you how to find that vertex one more time so that you could see it there. -2x squared plus 10x is what we're going to be plugging in for. Let's see if we can, it's coming up on this. Let's see here. It's coming there. So yeah, I'm coming to it in just a second, okay? Oh man, I've got actually some people out there right now. This is exciting. N-Dub, wow, I appreciate you for saying that. Keep tuned into these podcasts. I'm trying to update a lot of them on a consistent basis. Hopefully you're around the same unit that we're doing, and we'll try to keep you up to date. But I'm trying to podcast every day in class, and even some of the activities, trying to post those as well. So appreciate you for hanging with us. This is a little different podcast though, because we're going through some question and answer. We are snowed in Georgia right now, and so we have what we call a cyber day right now, and so that's why I'm doing more of a question and answer time. Off of, if you looked at the section 7.3 is the section that we've done previously. So just a heads up on that. So this is kind of a mixture. This is not just AP Stats. It's also pre-calculus as well. So just a heads up on that. But thanks for the love there. Appreciate it. Let's do this. Let's plug this in. -2x squared plus 10x here. And as we plug this in, we want to graph this accordingly. If you can't see it, you can always go to Zoom, and I always like to go down to Zoom Fit because it kind of fits it in there and fits it in that section on that. So if I was looking for the vertex, and again we already know the x-intercepts 0, 0, and 5, 0. I could find that on the calculator by going to second trace and going to the 0. But let's say that I was doing the vertex, which is the top value, and I'm going to get this. I'm sorry, I need to put this on there. There we go. Let me redo that, Dalton. My fault. So I go to graph. Here it is. If I'm looking for the vertex here, I go to second trace because it's a maximum. I go down to maximum, and I always go left of the maximum here. So as long as it's to the left of it, I press enter. The next one I do is I'm going to go to the right of that. As long as it's to the right, I press enter there. And then I'm going to guess over top of where that maximum is, okay? And when I do, I get a value, a maximum of 2.5, 12.5. So 2.5, 12.5 is my vertex. And then I can graph it, do whatever I need to do. So 2.5, 12.5 is my vertex. That vertex would be a maximum because of the fact that it's going downward, right? Because that -2 tells me that this parabola is going to go down, and therefore it has a maximum there. Dalton, that help you out? Do you have any questions on that? Any additional questions at all? If you do, let me know. I'll continue to go through it. Don't see any other questions that are here at this time. If you have any, again, additional questions, we'll continue that there accordingly. We'll keep going through that. Let's see here. Nothing there. Seeing if anybody had emailed me. Perfect. Perfect. Got some people turning in some assignments already. Wow, rocking. But do y'all have any other questions at all for me? Y'all have any other questions at all? Throw them up there. Perfect. Dalton, do you have any other questions that you have? And throw them out there. If not, I'll just kind of hang loose. And I may do an AP stats question if someone wanted me to. If not, that's fine. Again, I know a lot of you probably are just waking up, but I wanted to at least provide one opportunity for this. If this is helpful, leave something in the comments section or even email or text me. I'm just saying, Coach, that's really helpful. And then if you could, give me a time that works best for y'all. For me, I know I kind of like to do it earlier rather than later for those of you who have things going on later on. But if there's something that you would like to do later on in terms of doing this again, let me know. We'll go from there. Awesome. Dalton, thank you very much. I'm going to do an AP stats question, but Precal12, if you're here, I'm going to give you first priority on this. But if no one is here, I did want to at least go over this FRQ, providing a just providing an opportunity to go through maybe a tougher one such as this related to Section 7.3. So if you're looking at Section 7.3, this podcast section, this FRQ is spot on for what we're looking for. So we'll go through this one and then we'll rock and roll from there. As we read an FRQ, we want to make sure we break it down. What's it asking? What are we looking for? And what is the context whereby the answers support what we're finding? We're trying to use it and write in context. So it says that trains carry bauxite from a mine in Canada to an aluminum processing plant in northern New York State in hopper cars. Filling equipment is used to load ore into the hopper car. When functioning properly, the actual weights of ore loaded into each car by the filling equipment as the mine are approximately normally distributed. So heads up, when it is working properly, we're saying that the population distribution would be normal, okay? So we've got the normal check, and it has a mean of 70. So what we're saying is that my mu is 70, and standard deviation is 0.9, okay? So what we can assume is that this big N would be 70, 0.9 in terms of my population distribution. Now, if the mean is greater than 70 tons, the loading mechanism is overfilling. So if it goes past my mean of 70, we would state that it is overfilling, okay? So the question now becomes this. If the filling equipment is functioning properly, okay, so we're going to assume that all of this is true, what is the probability that the weight of the ore, and here's the key, a randomly selected car. Now, when I talk about the fact that it is one randomly selected car, we move from a sampling distribution and we go towards what our population distribution was originally. So we're saying within our population distribution, okay, the fact was that it was a normal distribution. That's the notation for normal distribution, big N. And 70 is my mean with comma 0.9 or my standard deviation following that 70. So I look right here and I look at my mean and I recognize the fact that my 70 would be right in the middle. Now let's keep reading. It says in a randomly selected car, what is the probability that the weight within that randomly selected car will be 70.7 tons or more? So what I would like to do is say, okay, 70.7 tons or more. Okay, so 70.7 or more is what I'm trying to find. And so drawing a normal distribution, the mean, the value that I have here, the 70.7, and anything greater than 70.7 is what we're finding. So what is the area of the highlighted area? Now, you could use z-score. I did that on a previous one. If you go backwards here to, I think it's this one right here. Perfect. This one right here actually was one that I used z-score on. So I'm going to use normal CDF here, and I'll show you the context that they're expecting on the AP exam. So we would put normal CDF, comma, lower bound, comma, upper bound, comma, mean, comma, standard deviation, okay? Then what I would be doing is I would plug in the normal CDF, and I'd actually plug this in, 70.7, comma, 299, I put infinity, sorry, 99999, right? Comma 70, comma 0.9, my standard deviation, okay? Now, when I plug this in, I get out 0.2183, okay? And so this would be my answer. Now, putting this in context, we want to make sure that we interpret this here. Another thing to remember too, this means that the probability that my X value will be greater than 70.7 is equal to 0.2183, or really what I would like for you to say is just restating what A says, okay? The probability that the weight of the ore in a single randomly selected car that's greater than 70.7 tons or more would have a probability of 0.2183. That would be sufficient, but you must interpret that to get full credit. Now, the next question is this. It says, suppose that the weight of ore in a randomly selected car is 70.7 tons. Would that fact make you suspect that the loading mechanism is overfilling the cars? Okay. So what we would say is, okay, based on the 0.2183, okay, we would want to look at this, make sure that, okay, what are they expecting there? Like, what is the answer to what we found in part A? So as I looked in part A, I noticed that the 0.2183 was here. We would say that, would that fact make you suspect that the loading mechanism is overfilling the cars? We would say no. No, we wouldn't suspect that, because of the fact that approximately 22% of the cars will have ore weights of 70.7 or greater when the filling equipment is working properly, right? So we would say that because of that, we would say that having a car that has a weight of 70.7 or greater than that is not unusual. The fact that 22% of cars will have ore weights of 70.7 or greater when it's working properly tells us that this event is not abnormal. And you could write that in a bunch of different ways. Well, you would say that this event happening would not be an abnormal event there, okay? So I would, again, just say that's how I would interpret it there, okay? Now, the next part is a little bit different, because now what we're looking for is if the filling equipment is functioning properly, what is the probability that a sample of 10 cars? So what we're doing now is we're moving towards a sampling distribution, okay? Now, because of the fact that the population distribution is normal, we do not have to show the central limit theorem. So the fact that there's 10 cars that we're selecting in this instance, we were going to now move and just say that since the population distribution is normal, the sampling distribution will have to be normal, to where n is mu of x bar, comma, standard deviation of x bar. Well, we remember that mu of x bar is equal to mu, right? So this would be the same thing. So this would be n with 70 at the beginning. This would be equal to 70. The standard deviation of x bar is equal to the standard deviation over the square root of n. So when I plug this in, I would put 0.9 divided by the square root of n. The square root of n would be square root of 10, which when plugged in would be a value of 0.285, okay? So that would be here, 0.285. So the question is still 70.7 or greater than 70.7, okay? The difference, though, is now we've got a sampling distribution. So the question now is, what is the probability that my mean, or we'll say X bar, is greater than 70.7? So as I plug in the normal CDF, I would do the exact same thing for sake of room, but I would do this exact same thing. The only difference is that the 0.9 would now be 0.285. We have less variability than we had before. So just a heads up on that. So when I plug that in, normal CDF, and I provided context here, the answer that I would get would be 0.0069 or 0.69%. Well, look and see what happened. The 0.2183 or the 22% turned into less than 1%. Even though this stayed the same, the sampling distribution has less variability because of the fact that we're averaging 10 cars together and we're not simply just taking one car. So the fact of the matter is that this is actually a more rare, or it's a rare occurrence, okay? So the question is based on the answer in part C, if a random sample of 10 cars had a mean ore weight of 70.7, would you suspect that the loading mechanism was overfilling the cars? And in this example, we would say yes in this case. We would, because the filling, we would say yes, we would suspect that the filling mechanism is overfilling the car there. And if it is working properly, and that's what we would say there. The reason why is that in 10 randomly selected cars, and I would say yes, the mean, or the maybe the mean probability, the mean weight. Yeah, we'll say the mean weight. Yes, the mean weight of 10 randomly selected cars that have a weight of 70.7 tons or more. Cars that have a weight of 70.7 has a probability, or has a, yeah, we'll say probability. We'll use probability of 0.0069, or you could say 0.69%, which is very small. And you could even talk about how that would be a rare occurrence, okay? That would be a rare occurrence there. But that's how you would approach this specific example. This is how you would execute it there, and that's how you would rock and roll it. I am getting a couple of different, I think I got a message or two here. Great question. Yeah, that's a great question. Someone asked, I know that sometimes the online version might be a little different than what is on the hard copy. Do the hard copy. If you ended up doing the online version, I would still give you credit for it. But because I've tweaked the homeworks around a little bit and adjusted the problems, I would make sure that for Precal12 that you take that into account. Answering questions right now. Gotcha. The FRQ 2008. It's a good question. Let me do this. I'm trying to see on my hard copy here. Yeah, this one. Sorry. I'm looking on the hard copy to see. I see the 2008 one, Jordan. Checking right now. Might have, did that get nixed? That might have gotten nixed on there. See the 2008 one. Yeah, do this. I'll show that up real quick. I know it's on the online version. Jordan, that's a great question. Let me see if I can show this here. Let's see if I can pull this up for us. Here we are. I'm going to pull this one up. My apology on that. I think there was one page of the solutions that I didn't get in there. It is online. I know it is online. It is on the document here. The 2004 one. It's underneath FRQs if you go to the very bottom of that page, but I don't think I did get the answers, the solutions to that. But so that's my fault. But here, let me do this. Let me get this up. See, Jordan, hopefully you can see this on my screen here. Let's see if I can pull this up. Here, let me see if I can pull this over. All right. Hopefully this makes sense here. You'll see right here, to get credit, they did the Z-score part. I hope this makes sense, but this is the 2004 one. So you see here, like, here's the part A that they utilized, the 0.2177. If you got a little bit off from that, that's okay, depending on how you plugged in your calculator. Just make sure you, again, establish context. You'll see here the part B here, part C, and part D. Show how the probability is computed. Yeah, right here. This is what we did for the part, the notes here. So to get credit, we did this part. Trying to see if there's anything else I wanted to say on that. Gotcha. Yeah, I don't think there's anything else on that I would hit there. I think that's it. The one thing make sure. Gordon, yeah, if you have any questions on it, let me know. Jordan, if you could do both, that would be great. Both of those FRQs. Again, really, to be honest, you're going to submit it online, and I'll just kind of check to see if you did it or not. My big thing, the reason why I'm doing it is not to give you more work. These were supposed to be due next Monday anyway. So I just wanted you to kind of get practice on 2 FRQs, and then also start kind of getting your work done for what will be next Monday there. So that was kind of the purpose behind it. I know the podcast was a little bit lengthy, and that was my apology on that. But I was trying to just go through a lot of that information. That way you've done that. And then especially the one we just did, this FRQ that we just did was kind of the all-encompassing FRQ for the podcast on section 7.3. So just a heads up on that. There. If y'all have any other questions, keep posting them on here. I'm looking right now and seeing if anybody has any, throw it up there, and we'll look at it together. So I'll wait right here. You're welcome, Jordan, anytime. Again, if you have any other questions, I'll kind of hang out here for a little bit longer. If you got any other questions, let me know. Let's see here. Didn't want to see if I can. Let's see here. Got any additional questions? Continue to throw those out there. Pull that up. Yeah, that'd be great. Let's do it. Let's go through numbers 9 and 10 on 2.1a. Again, we're looking at the hard copy one right now, specifically in Precal12. So we're going to look at those questions here, and we'll rock and roll. Okay, rock and roll. All right, people are responding to this. Great. All right, we've got literally I think we may have Sweden followers. This is really good. I know I was joking about it, but this is getting fun. All right, so let's do this. Let's go to let's see if I can pull this up here, and then we'll go to 9 and 10 on the podcast here. Let's see. Or on 2.1a. All right, 9 and 10. The sum is 110. It says find two positive real numbers whose product is a, and I think it might have gotten cut off, but it's a maximum. And then it says solve the real world problem. Here's what I will do. I will tell you that the number 9, for those of you who watch the podcast, number 9 is on the podcast, okay? The sum is 110, so that's the one. Look at the very end of the podcast. So if you look at that, x times y is a maximum right here. So we say x times y is a maximum, and then I said the sum of these two is 110, or x plus y is 110. And then I actually show on the podcast how I plug one into the other. So check out that last one. And we'll rock and roll off that. Chris, does that make sense? I hope that makes sense. If you go check out that last podcast for number 9. Now, number 10 is a different animal. That one is a tough one. I wanted to actually, that was a good one to go over. So 9, look at the other podcast posted at the top of the on-campus page. And then number 10, we can look at together here by by doing the following problem. So let's do this one together, and we'll rock and roll there. And here we go. So we've got y equals negative 16 over 2025 x squared plus 9/5 x, and then plus 1.5. Okay. So we've got the quadratic here. And in order to kind of attack this one, we've got to see what are the questions they're actually wanting us to do. And because of the fact that this one is a little more complicated, it's not as nice and clean like with whole numbers or values that we could do by hand. The expectation here is to put it into a calculator and be able to solve for it and figure it out from there. So simply what we're going to do is, if you got your calculator, I would take it out, or if you don't, then just watch on with me, and you're going to see this kind of go down here in a second. So I'm going to get this down first, but you want to make sure that the parentheses are around the fractions. It's important. Okay, so just be leery of that. And you'll see here in a second, for those of you who are like, well, coach, we can't see it. I know you can't. I'm getting this in, looking at it myself before I okay. And I'll come back up. So I'm going to minimize this. Everything we're going to do on number 10 will be straight from the calculator, okay? So let's look at this one. Okay. So right here, you'll notice that I just simply put in the equation of negative 16 over 2025. Notice that the fraction must be in parentheses. Make sure you use the negative sign, which should be here, not the minus sign, because it'll throw back an error to you. So we got x squared plus 9/5 x plus 1.5. So once I plug that in for y, I just put graph here. But you'll notice that this graph is kind of weird because it takes my window from my previous problem. And so instead of just leaving it like this so I can see it, I always go to zoom and go towards the bottom. You could try zoom standard. For this one, you probably want to go like zoom fit. Let's see if that'll fit it there. See, it's still just a line that doesn't really tell me the full picture. So that's fine. We try different things. So we're going to go to zoom out. Okay. So once I press zoom out, you'll see that there's a cursor here. And what I'd like to do is move that cursor to where I focus more on what's happening on this right side. So I'm going to press enter. See if it does it. It's getting closer. Okay, so I'm going to go to the right a little bit more. See, right up here, I'm going right and up just so that I'm there. And anytime I press enter, it'll zoom out at that spot. So that's why I want to make sure I kind of zoom out over here. That's a much better, but let's do it one more time so that we can see the full picture. And we'll zoom out right there. There you are. Okay, so the punt that we're looking at is from here as it's being kicked over in this vicinity, over this direction. Okay, over in this direction. So let's look at a couple things. First off, we can look at what is the highest point of this graph. So to make it easy on ourselves, we're looking for the vertex. So in order to go to second trace, we'll go there, and then we'll go to the maximum, and we'll go to the left side of the vertex. So if this is the maximum, we'll go to the left side of the vertex, press enter, okay, because that's what it says. Left bound, meaning to the left of the vertex, press enter there. Then it says right bound, so I'm gonna go to the right side of that vertex, and then my guess is somewhere in between, okay? So as I look at this, this means that at the height of my punt, it is 113 feet to the right and 104 feet in the air. So the highest point, the punt is, the highest point the ball is would be 104 feet in the air. That would be my vertex. Okay, so now I'm going to go back to second trace here. Because it's going downward, right? It's going down. We know we're going to look at a maximum. Oh, we already did that. I'm sorry. We're going to now look at our zeros, right? Where does it cross the x-intercept? The left side's not as much a concern as how far it travels till it hits the ground. So the x-intercept is where it hits the ground. So when it says left bound, we want to go to the left of that zero. So press enter. when it says right bound, we're going to go to the right of that 0. So if the 0 is here, we want to go to the right side. And when we guess, we want to go somewhere in between. So the distance the ball travels from the initial spot would be 228.6 feet to the right. And that's how we would solve that there. Now, I think that is it. There may be one other question. I think there might be one other question. Let's see. I'm going to pull this up here. Pull this part up. Let's see here. Okay, right here. Notice that this says how high is the ball. We found that. And remember that this punt is that little area above my x-intercept. So just a heads up there. So we found the height. I think it was 104. I think this was like 200 something was the distance where it traveled there. So that we're talking in terms of feet, in feet. So the question is how long? We got that. What is the maximum height? Got that. How high is the ball when it is punted? So when the punter punts the ball and it starts, where is this? So this would be like my y-intercept, okay? Because this would be the y-axis up and down. So what is the y-intercept? Well, y-intercept, you can't find on your graphing calculator. However, what you could do is you could just solve it algebraically. So y-intercept, you plug 0 in for x. But when you have 0 times something, that's 0. Plus 9/5 times 0 is 0, plus 1.5. So my answer in terms of the height from which it's punted would be 1.5 feet. So that would be the initial spot when it's punted, 1.5 feet. You got the height, you got the distance, and that's what we're looking for there, which is what's expected, what they're looking for. Okay. Great. I love the questions. Chris, does that make sense? I hope that makes sense there. That helps you out. Hey, do y'all have a lot of snow? I think y'all probably have a ton of snow over in Gwinnett is what I saw. We got quite a bit here as well. Chris, also, do you know number 9 is on the podcast on campus? Just a heads up there, okay? Yeah, so Torrance, if you could take a picture, upload it to On Campus. I use Cam Scanner. Cam Scanner is really good. Cam Scanner is great. Also, you could take regular photos and post it. I like for it to be one document. It makes it much easier to look at. On Cam Scanner, makes it a lot easier to just make 2 documents, one, so that it's just easier to go through. I don't have to keep having all these downloads coming in. So if you could do that, just makes it cleaner. But that would be rocking. I believe I posted that on there for y'all to post on it. Let me just make sure. Let me make 100% sure. As I say that, I wonder if I put an on campus. I think I did, but let me make sure. Yeah, I think that'll be good. I just posted that, just changed that. Let me see the Precal 12, make sure. I'm pretty sure the Precal 12 is there. Again, you're going to really, for those of you doing 2.1A, you're going to get double the credit for this, which is pretty cool. So if you got it, turn it in. Most of the time it will be hard copy. I know this was after all I said about trying not to turn it in online if you've got it hard copy. I know that makes it a little frustrating, but with Cyber Days, it kind of throws things off just a little bit, okay? So, yeah, just let me know if you've got any other questions. Y'all have questions, I'll kind of hold tight here. For a lot of you, no sporting events today, whether competitions or practice. And who knows what's going to happen tomorrow. I'm curious to see if we'll have school tomorrow. Curious a little bit. If we do not have school tomorrow, I will probably do an additional podcast for Precal 12. We'll do probably another 20-minute podcast to go over section 2.2a. Might do that. And AP stats, we'll probably do a review activity. I've got an idea of what we could do, something just a little different. So we'll do that as well. Post it and rock and roll through that. So we're going to try to do that together. And we'll go forward with it. But if no other questions are here, waiting just a little bit longer. I'm going to close shop here in just a little bit. So if you have any last minute questions, come on. This was well attended. I appreciate it. Appreciate y'all's help on this, making it such a success. And keep everything going. Keep it rolling there. Okay, I'm going to close up shop. Hopefully this was helpful. If you have friends tell you, hey, did Coach Dave post that podcast? Send them the link. I'm not going to post it just because it was all over the place and with AP Stats and Precal12. It was more of a help session, not a study, like a study session for one class, so I won't post it. But hopefully this was helpful. Have a great Cyber Day. If you have any other questions, email me, text me, whatever. I will be available for y'all. See y'all.